Welcome back to the GCSE Maths Pro YouTube channel. In this video we'll be looking at how to rearrange harder equations. So this is a very specific type of equation where you might see that the letter you want to make the subject appears twice. This is specifically for higher tier students. This is not an explanation of just general rearranging equations. You will need to know how to rearrange equations in a basic way first. This is then the extended version, as I said, for higher tier students. So there are actually two types of equations I kind of want to highlight here. One is where you have the letter that you want to make the subject in the denominator of a fraction, specifically the denominator, not the numerator, but the denominator. The second type is where that letter will appear twice in the equation and they're not like terms. So we'll start off with this one where we've just got the letter P that we want to make the subject of the formula is in the denominator of the equation. Currently, M is the subject, isn't it? Just to explain what the subject means. The subject is the letter that's kind of on its own on one side of the equation, and then everything else is on the other side of the equation. So here, M is currently the subject. I want to make P the subject. So my goal is to get P equals, and then whatever else, everything else on the other side. So that's what I'm looking for as my end result. One mistake that I think students make when you've got a letter in the denominator of an equation is they think that you can't move that letter or the letter that you're trying to make the subject. They think that you have to move everything else around it and not that letter, but technically you can move any term in an equation as long as you obviously move it correctly. So in this case, because P is not only kind of locked inside this square root symbol, it's also locked kind of inside a fraction, isn't it? And I want to have P as the subject. I don't want it in a fraction. I'm going to have to try and open all of that up. A lot of the time with rearranging equations, there are kind of 2 or 3 different orders that you can do things in. So if you end up working this out in a different order to me, then that's fine as long as we end up with the same answer at the end. So don't necessarily worry if you thought of using a slightly different order to me. As long as it makes sense to you and you have got the correct answer, it shouldn't matter to that level of detail. So my thoughts here are, we've got 2 options. We could deal with the fraction first, as in, when I say get rid of the fraction, I mean obviously multiply by whatever is in the denominator, that will open up the fraction. Or you could get rid of the square root symbol if you really wanted to by squaring everything first. So it's up to you which you prefer. I think naturally in my head I was thinking I would probably deal with the fraction first, but you might think differently. That's fine, just go with whatever instinctively makes sense to you. So as I said, to get rid of the fraction or to move the P out of the denominator of the fraction, I'm going to have to multiply by the whole denominator because obviously a fraction means divide. So do the opposite is multiply. So multiply both sides by the square root of P plus 1. So I've got M here, I'll just leave that kind of like a coefficient. Square root P plus 1, that's all multiplied together. And then it's not 0 on this side, right? Technically the 1 from the numerator is still there, so that's a 1. So I've got rid of all my fractions now. I think it's always a little bit easier when you don't have a fraction to deal with. Now the next thing is obviously, as I said, P is still kind of locked inside this square root. So what I would probably do now is we want to obviously have P on its own on one side of the equation. So I think I would move the M across. So it's almost like we're swapping the M and the root P plus 1. So obviously I would have to divide that, wouldn't I? Because as we said, it was currently a multiply symbol, wasn't it? So divide. You can obviously do that in one step if you like. Divide by M. If you're more confident, you can do that in one step. So now is when I would naturally deal with the square root. I obviously want to open that up, so I'm going to square both sides of my equation. On this side, it just opens up and becomes P plus 1. And then on the right, you could obviously write it, as a fraction squared, but you can also actually work that out. So 1 squared is 1, M squared is obviously M squared. So 1 over M squared. And then you can see from here now, this is kind of the more straightforward bit, isn't it? I'm going to subtract 1 just to get P on its own. So that's the way that I've ended up getting it. As I said, you might have dealt with it differently. You might have squared things first. There are different ways to do it. As long as you've got some version of this, it might not look exactly the same as this, but as long as, mathematically it is the same thing, then that's fine. And we've made P as the subject. So don't forget that you can move the letter that you want to make the subject. You can move it around. That's absolutely fine. Okay, this next one is kind of similar. As you can see, we've got a letter in the denominator, but it's slightly more complicated because we have a few other terms as well. So make A the subject of the formula, B is equal to C minus 6 over A. So as I said, we want to make A the subject. That means A equals and then everything on the other side. It doesn't really matter if the subject is the left side or the right side. That doesn't matter. As long as you've got that one letter on its own on one side of the equation, then it becomes the subject. As I said, again, there's loads of different ways to do this. I try to follow the route that, at least in my head, makes the most sense in terms of is the easiest, is the route that I'm less likely to make mistakes on. That's up to you. You might have a different kind of mentality on it. The first thing that's shouting at me is the fact that the a term, or this whole fraction, is negative. And when you have the subject, it has to be positive. So what I would personally do is probably just move the 6 over a across to the other side of the equation, because that would make it positive. You could obviously just multiply or divide the whole equation by -1. That would change all the symbols. You could do that as well. I prefer not to do that. I prefer to just add something across to make it positive. So I end up with this. 6 over a is now positive, plus b equals c. Now, as we said, we obviously have to multiply by the denominator of the fraction, which happens to be a in this case, because I don't want the fraction. I'm trying to get a on its own. You could multiply across by a right now if you wanted to. That's fine. But this is kind of why I would probably avoid doing this, is because a lot of students would make the mistake of obviously getting rid of the a here. That's fine. If you multiply by a, it cancels out, and then multiplying the c by a. Now, those two things are technically correct, but you're missing the fact that everything has to be multiplied by a. So if you think, oh, if I multiply by a, I wouldn't think to multiply the b by a as well, then I would probably avoid doing that. If you're happy that you know that every term, when I multiply by something across the whole equation, you have to multiply every term by that. So there's 3 terms here, not just 2, then that's fine, do it that way. But if you're not sure that you're going to remember to do that, then I would suggest this other method. So the way that I would do it is I'd go, let me just isolate the fraction on one side. So I've made it positive, but let me isolate it. Let me get it on its own. So that means let me move the b out of the way, obviously by subtracting. Now, I think in my head it's more obvious. Obviously, I am going to multiply by a still. We're still doing the same steps, just in different orders. I am going to multiply by a to make it no longer part of a fraction. But as you can see, obviously that would cancel out there, so I get 6 on the left, and then a multiplied by both c and b. So it kind of automatically happens because I'm multiplying the whole of the right-hand side. So I think that's a bit more obvious. It's a little bit easier to not make a mistake there, but it's up to you, whichever makes sense to you. And now hopefully you can see that the final step, I'm not going to expand anything. I know you kind of naturally want to, but I'm not going to expand anything because I want to get a on its own. So all I have to do is just then divide by the whole bracket. Divide across by the whole bracket, so 6 over c minus b. As I said, it doesn't matter if a is on the left or the right, as long as it's on its own on one side. This is what I've ended up with. So that's the method that I would take. As I said, I kind of pointed out there's kind of different steps or different orders to the steps that you might have done differently. As long as we've got something that is mathematically the same as this, then that is absolutely fine. Now, this one kind of naturally leads on. You can see that we have got a letter in the denominator of the equation, but we've also got it twice. I know that I've seen this type of question come up a lot with particularly EdXL higher tier, maybe also AQA, but it's where we've got obviously a fraction. Most of the time you've got a fraction, but also the fact that the letter that they want you to make the subject, so in this case we want to make x the subject, appears twice. So you can see we've got a 4x and then a minus x here, part of a fraction. So we're kind of building up each time, making it a little bit harder. Now, this one, again, pretty straightforward to rearrange once you know the trick at the end. So what I would do is we don't want to have, obviously, our denominator kind of the same as the previous question. We don't want that denominator. So what I would do is I would just straight away multiply across the equation by the whole of that denominator, 3 minus x, just to open up the equation. There's no fractions, nothing's kind of locked into a fraction or anything like that. Let's open it up. So I would end up with y multiplied by 3 minus x is obviously equal to the numerator, which was 4x plus 1. So what I would do now, because thinking of trying to open up the whole equation, we've now got brackets. We've got the 3 minus x, which is still kind of locked into brackets. Let's expand that as well. So we get 3y and then minus xy. Might seem a bit counterproductive because now we're mixing the x's and the y's, but that's fine. So multiply across, get rid of the fraction. If there's any brackets that you need to expand, expand everything. Do you see how now I've just got a completely open equation? All of the terms are just there. There's nothing kind of obstructing them. They're all there. The next thing you're going to want to do with this type of question is get whatever letter you're trying to make the subject, any terms that have that letter, get them on the same side. Any terms that do not have that letter, move them to the other side. So here, can we see, let's highlight, we've got the negative xy, that's got an x in it, and we've got 4x. So those are the terms that do have the x. Obviously then the other terms, 3y and 1, don't have an x. So I kind of want to get the pink ones together on one side and the green ones together on another side. The way that I decide whether to move them left or right just depends on what you get in terms of positives and negatives. If there's a way to keep the majority of the terms positive, I would move it in that direction. Sometimes it doesn't really make a difference. So in this case, for example, I would probably move the xy to the right, because to move it, that would mean adding it. So my 4x is positive, my xy would become positive. Obviously, I would then have to move the 1 across, which would become negative. But then, do you see how only one term would be negative? I would do it that way. It doesn't matter, technically. It doesn't matter. I'm not saying this is right or wrong. I would just choose to make the majority of the terms positive if I can. It's not wrong if you don't, but I just feel like negatives look a bit messy. That's just me. So that's what I would do. If you moved it the opposite way, so let's say you moved the 4x to the left because you naturally feel like you need to put the x on the left. You don't have to, but that's also fine. Do you see how the xy would be still negative and the 4x would become negative? And then also you then move the 3y across, that would be negative. So out of 4 terms, I'd have 3 negatives. It doesn't really matter ultimately. I'm just kind of trying to keep things as tidy as possible. And I feel like positives are a bit easier to work with, aren't they? So I'm going to move it this direction. So what I'm going to do is we've got the 4x. I'm going to add the xy. That makes it obviously a positive. And I'm going to subtract the 1. See how that's fairly nice? I just visually think that's nice. So that's completely up to you though. It doesn't matter if you've ended up with all negatives as long as you then go on to deal with the negatives properly. Because also remember that the subject has to be a positive. Okay, so now we're at the stage where you're thinking, okay, yeah, I've got all my x's on one side, but I cannot literally add them because they're not like terms. You see how one's a 4x and this one's an xy? They're not like terms. So this is where a lot of students get stuck. And this is the one trick that you need to remember. I don't feel like it's something you'd naturally think to do when you're rearranging. You just think of adding, subtracting, multiplying, dividing, maybe squaring, square rooting. We don't really tend to think about this because it is only on one side. The way that I can get the x's together is by factorising. And I mean that in terms of a single bracket. Do you see how both terms have x in common? So that's the common factor. So I can pull out x, leave the 4, and leave the y. So it's kind of a little bit like the previous question where we ended up with the a and then the c and the b inside the brackets. So just remember you need to factorise. Obviously that doesn't affect your other side of the equation because we've not moved anything. It's just changing the format. So I've got my x together. This is the key bit just to remember. Factorise. Get all the terms with that letter in on one side and then factorise that letter out. Let's put it up here, shall we? So all I need to do now is divide by that bracket because remember just generally brackets is normally something to do with a multiply, isn't it? So the opposite process to move it across to the other side of the equation would be to divide. So that's what I've got. Now, as I said, if you did move the terms in the opposite direction, you'll get something like this, but probably different symbols. So let's just maybe quickly write it over here. Let's say if you did the opposite version and you moved minus 4x minus xy to the left and then 1 minus 3y on the right. When you come to factorise out the x, I know that technically you can factorise out a negative because they both have a negative in common, but obviously we want the subject to be positive. You'd end up with a bracket which is minus 4 minus y is equal to 1 minus 3y, and then you would divide by that bracket. So the steps are still the same. I don't know, visually it feels messy to me that there's so many negatives when there doesn't need to be, but it is technically still correct. They would still give you the same marks, they would still give you the answer if you wrote this or this. But do you see how I just chose the version that led to having fewer negatives? That's the only reason. So you've got either of these two answers, they're both the exact same thing. You can just see that the symbols are inverted. Okay, so I've got another one that's very similar to that one. There's just, I guess, a little bit more going on here, but the logic is the same. We want to, first of all, open up the whole equation. So get rid of any fractions, get rid of any brackets, expand, multiply, all of that first. So that's kind of my first step. We want to make w the subject. So you can see here w comes out twice. So what I would do is multiply by the denominator. Maybe if I put it over here, we've got some more space. So v multiplied by 5w plus 4. And then on this side, we've got minus 2w minus 1. So in this case, all I would probably do is just expand both sides. So 5vw plus 4v. is equal to minus 2w, be careful with the negatives here because it becomes a positive, plus 2. I've expanded everything, I've got rid of the fractions, everything's now opened up. Our next step is to then get all of the terms with w on it on one side and all of the terms that do not have w in them on the other side. So here, I think this one's straightforward. This one's got a w, this one's got a w. These two don't. I think I would move my 2w across because I need to add it to make it positive, and then just move the 4v to the other side. That's the way that I would do it. As I said, if you do move it the opposite way to that, you'll still get the same answer. Just the symbols will be the opposite of what I've got. So I'm going to add 2w because then that, or at least that side's all nice and positive. And then take away the 4v. So I've only got one negative again here. If you do it the opposite way to me, you'll probably end up with 3 negatives and 1 positive. Which is fine, as I said, it is fine. Just looks a little bit messy in my head. Once you've got all of the terms with w on one side, this is our key bit. We factorise out the w because that's what we want as the subject on its own. So factorise out w, and your final step is to just divide by that bracket. So w is left on its own, 2 minus 4v in the numerator, and then 5v plus 2 in the denominator. So there we go. Do you see how that was basically the exact same steps as the previous one? So if you've got this scenario where you've got a fraction, you've got 2 of the same letter, step 1, open it all up, whether that's multiplying to get rid of the fraction, multiplying to expand out the brackets, get all of the terms with that letter on the same side, and then factorise and divide. So it's kind of 4 steps, I guess, 4 steps, but they are quite repetitive, which I think is nice. So once you know how to do that, it is quite consistent. Okay, this one is similar. The only difference is it's not set up as a fraction currently, but it's kind of the same idea. So you can use the same logic to figure this one out because it says make h the subject of the formula 7h plus 2 multiplied by 3h minus 1 equals g squared plus gh. So you can see here we've got multiple h's and you can see that 2 of them have numbers, so that's fine. But the other one is mixed with another letter. So we've got this exact same scenario. The only difference is it's not in the format of a fraction to start with. So I'm still going to kind of try and open everything up. So in that case, that just means expand this bracket here. So 7h plus 6h minus 2 is equal to g squared plus gh. Now, what I can actually do in this particular case is simplify it, collect the like terms, because these 2 h's here actually can be added, can't they? So do that if you need to, or if you can. So that would be 13h minus 2 on the left, g squared plus gh on the right. Now we're kind of carrying on with the same steps as before. Get all the terms that have, in this case, h in them on one side, and then the other terms that do not have the h in them on the other side. So I'm probably going to add the 2 and then take away the gh, that's my thought here. So 13h minus gh is equal to g squared plus 2. Again, do you see how I've chosen a direction that just means that at least the majority of it can be positive? That just, I think, is easier in my head. But you could have obviously moved them the other way around if you wanted to. So now that I've got the h's together, hopefully again you can see it's exactly the same step. The only way that I can actually just have one h on its own is by factorising, because they're not currently like terms, so I can't literally subtract. So I have to factorise out h. I get left with 13 minus g in the brackets. Obviously on the right I still have my g squared and then the plus 2. And then the last thing is divide by that bracket. So you see how that was the exact same steps. The only thing is that the setup at the start might be slightly different, but once you've opened everything up, from there the steps are pretty much the same. So that is everything you need to know about the higher tier version of rearranging the harder equations. Hopefully you just remember those steps. Remember that you can actually move the letter that you're looking to make the subject. You can move anything you want, so definitely move that letter. And the key thing was to factorise in those scenarios where you've got 2 of the same letter, but they're not like terms. So thanks for watching this video. If you found it helpful, make sure to like and subscribe, and leave down below any questions or comments that you might have.